Hello and welcome to this fifth workshop by ISSMGE TC222, Geotechnical BIM and Digital Twins. The subject for this workshop is the second part of the National Geotech Databases and Asset Registers. Let's see if I can shift slide here. Okay, so this is the agenda for today. First, a short intro by myself. My name is Magnus, and I'm chair of TC222. Then Michael will start with the session before the presenters follow up, and then Michael at the end will also have a wrap up of the workshop. We are using Slido for Q&As. We will have a Q&A session after each presenter. So use the QR code or use the link if you can, or you can just go into slido.com and push in use the code given there to access the Q&A area. This will also be shared in this chat, I think, yeah, or we share it later. I think Michael also has a slide with this. So, as always in our workshop, we will just like to have a short introduction of the TC. So we are a part of the International Society of Soil Mechanics and Geotechnical Engineering. And this is a society with 90 member societies and around 20,000 individual members. There are 37 technical committees like us, and we are the number 222, which is about BIM and digital twins for geotechnics. More information about ISSMGE and also us is to be found on ISSMGE's webpage, issmge.org. So the TC222 Council, as I said, I'm chair of this, and together with me I have Michael, which is vice chair, Mats, which is secretary, and also Jelena and Raymond, which are core members of the council. So we are the ones who are running the TC and doing the planning for all these workshops and the other stuff we do. You can follow us on our website, which is part of the ISSMGE website. But most of the information we send out is through LinkedIn. So if you want to keep up to date, please follow us on LinkedIn. And we also have a YouTube channel where we put the recordings from these workshops. So today's workshop is recorded and will be shared on YouTube later. So yes, so everything is available on YouTube, or at least almost everything is available, because we had some issues with the recording from the last workshop, the fourth workshop. So the recordings is lost somewhere in the Microsoft universe. This means that we're now trying to gather all the presentations at GitHub, so we can share the presentations or the slides with you in GitHub. This is a little bit work in progress, so we are not finished so far, but everything will be available there, hopefully, as long as it is okay for the presenters to share their slides at GitHub. But the first three workshops are available at YouTube. There we can also find our interactive technical talk, which is a workshop series that is set up by the ISSMGE. We are part of number 17, which was moderated and led by Michael. And this is also to be found on YouTube. But here it's not our YouTube channel, it's the channel of ISSMGE where we have to access to see this. If you want to become a member of the TC, you have to get in touch with your national society. It's a national societies that has to suggest members for the different TCs, so you have to talk to them first. If you're not sure about the name of the society or who's your contact person, this is also very easy available on the ISSMGE webpage. Back in August, we had our first ever physical TC222 meeting during the European conference in Lisbon. This was a very nice event and very inspiring event for us. From the core team of the TC, it was Mats and I who was present, was at the conference. And then we had participants from Japan, Turkey, Sweden, Germany, and Portugal. So yes, again, this was very inspiring and fun, and definitely something that we have to do again. One of the challenges is to find the right conferences where a lot of our members are present. So that's something that we now are discussing. Where will the next physical TC222 meeting be? And until we are having the next physical, we will continue with these digital workshops and meetings, and hopefully spread the information to both the member society, but also the entire geotechnical society. A place that we definitely will have a physical meeting, I think, is during the international conference, which is going to be held in Vienna in June in 2026. Here, the abstract submission deadline is at the end of November this year. So you have a little bit more than a month to write your abstracts and send them into the conference. What is important here is that the conference has choose to then have the topics of the conference in line with the name or the topics of the technical committees. This means that when you send in your abstract, you have to select one primary and two secondary TCs that your contribution should be assigned to. This is important because, again, at the end it will be the different technical committees that plans and carries through the different sessions at the conference. Which means that if you write an abstract and assign it then to TC222 and our work in BIM digital twins, then the paper will potentially be part of our session during the conference. So I hope a lot of you send in abstracts for the conference in Vienna, and I hope that we get a session or two with a lot of very nice presentations within BIM and DTs in geotechnical engineering. That was all from me. Then you can take over, Michael.
Yes, thank you, Magnus. So I will also try to share my screen and continue with this specific workshop. Do you see my screen?
Yes, we do.
Cool. So, as Magnus said, I'm Michael Beaufils from the BLGM, Geological Survey of France, and I'm very happy to be here with you for this fifth workshop that is following kind of a series we launched. So, back in April, we discussed the topic of standardization. People that know me know that it's a very important topic for me. And we had an overview of the existing standards. And then there was the idea between what we have in terms of standards and what are the daily life, what are the database we have in geological surveys and for asset register, how they are implemented, how they are used, and what do we have as accessible resources for our daily work. So this workshop number 3 provides us some interesting information about important ingredients for big database and data exchange. And so that's why we launched this series about the national geotech databases. So as Magnus mentioned, there was a previous episode, there was a chapter 1, in which we had the presentation of 4 institutes. So Polish Geological Institute, information from Institute of Mountain Hazards and Environment in China. We also had some interesting feedback from TNO, the Geological Survey of the Netherlands, and we had some information about the National Underground Asset Register in the UK. So these were people that launched this activity about what are the current status in terms of database in those countries, both in terms of how the data can be provided, but how they can be also made available. So unfortunately, we don't have replay for that one. The idea is that we will, of course, get some information from them. There are already some presentations that are available, but we will get in touch with them in order to, make sure that what they presented would be available in one way or another, because these were very relevant material for this topic. And now we will have this chapter number 2 with other countries that will present what they have. I will just introduce what is the topic of this workshop. We know that there is 2 things to take into account. So what you can expect is that from a national database, you can have some resources that will be available for your project. So for example, if you are building a tunnel, certainly you will try to get some information about what is existing on the site from some database that are made available by your local survey or some other organization. And also what is interesting to consider is that when you are doing some activities, when you are collecting new data in terms of geotechnics, there are things that could be useful for understanding the soil of the countries, the underground of the countries. And so there can be some contributions to build a national database to make it bigger. So you can see there is a kind of cycle of how a bigger database can be more useful for your project. And so how a national database could be used and fed by the projects. So questions that can be addressed today, if we are talking about national geotech databases or asset registers, which services are offered? How is the national database field, so the 2 sides of the topic? Governmental support. Is there some existing regulation in the country? How did it happen? What is the current status today? And also we will address technical aspects, so have more information about what are the formats, technologies that are probably behind those national database. So there can be interesting information for you if in your country you would like to have such a project happening. So today we will have 4 presentations for Insight from Switzerland with Stefan, from Finland with Hilkka, from also Singapore with Stevan, and also at the end we will go back to the UK with Edward. So as Magnus already said, if you would like to share some feedback, ask some questions to the presenters, please use a Slido here, and I will be happy to ask them in order to have some live discussion. So here is all from my side, and I would like to invite Stefan to share his screen and to start the first presentation.
Yes, can you see my screen?
Yes, looks nice.
Okay. Thank you very much, Michael, for the introduction, and good afternoon from my side. I'm really pleased to give you an insight to the BIM Monterrey project, and I will directly start at the beginning. First, I will give some information about the location of the Monterrey Rock Laboratory. You can see here the map of Switzerland, and in the northwestern part there is lying or is situated this rock laboratory. You can see here these folded Jura Mountains. You can see here the village of Saint-Urzan, and here is the motorway tunnel, and along this motorway tunnel here is 300-meter underground is the Monterrey Underground Rock Laboratory. There is also a visitor center, so you can visit the laboratory, and you can see here in this image that it is a kind of a tunnel system. It's a length of 1.6 kilometer approximately. And what is done in this rock laboratory? So this is an international project, so international research project 28 years of research into the hydrogeological, geochemical, geotechnical characterization of a clay formation that's called the Opalinus clay. You can see down here in this geologic cross section the purple area. This is the the formation of this Opalinus clay. The white line is the motorway tunnel. The red line is where the lab is situated along the security gallery. And here, this Opalinus clay is the only proposed host rock for high-level radioactive waste in Switzerland. So with this research work they're making a significant contribution to the safety and technical feasibility of a deep geological repository in the Opalinus clay. And what about the partners? So these project partners, there are 22 partners from 10 different countries, and there are currently 46 experiments ongoing, and 122 are already completed. Now I have to say something about the expansion of the laboratory over the last 28 years. Here you see the motorway tunnel, here you see the security gallery, and in 1969 they started with some niches. And then there was the first new gallery in 98, then in 03, then 04, the next gallery 08, 2012, and then in 2018 they almost doubled the size of the laboratory, and there you can see it gets kind of a critical size, so this has influence to the management of the laboratory. And to see this, I will show the task of SwissTopo at this Monterey Rock Laboratory. Here is a team of the SwissTopo Monterey team. And the tasks are management of the international Monterey project, the operation of the rock laboratory, ensuring the underground safety, planning and conducting own experiments and supporting experiments of partners, then the communication, as well as internally with partners and externally with authorities, research institutes, industry or population. I mentioned there is a visitor center, you can visit this. And how we can now with BIM or with a kind of digital twin support the work of our colleagues there. For this, we defined use cases for the BIM Monterey project. So very important is the interaction between geology and the laboratory infrastructure. You can see here in this Lego image that there is the geology around the, let's say, of the construction site or construction building. So the geology is actually the building, kind of. And inside you have this infrastructure, and the interaction of this is very important, especially in the Monterey. There, the whole topic is geology. So you have about 1,400 boreholes inside the laboratory from all the experiments and so on. And then you have a 3D model of the geology with the different layers there, and the layers that they are interested in to perform their research. And like this, there is a big interaction between the built infrastructure, man-made, and the geology. I want to give a little background to another project. It will be very, very short because I have just 20 minutes. So there was a project called GeolBIM Innovation Project. This lasted from 2020 to 2022. And the target was the integration of geology into the BIM method using case studies in the 3 use cases considered: tunnel construction, subsoil, national hazards. And there we wanted, here you have the coordination model, you have the domain-specific models like architecture, terrain, and so on. And we wanted to add this geotechnical engineering and geology to this part. I added this slide. I don't go really in detail here, but as the slides are shared, you can have here and look at the link. So there is the final report of this project, also available in English. There is a GeoSimul-based GeolBIM data model, and there is an app where you can see how to use this. There is a video, a tutorial. But now back to the use cases of the Monterey. The second use case is to create an inventory of the laboratory infrastructure. So these mean kind of a retro BIM. So all the infrastructure is already existent, and we want to create a BIM of this infrastructure, and also including the geological objects, so interaction up here. And then the next use case is to develop an IFC interface for collaboration exchange projects. So here's an example. If you want to make another expansion of the laboratory, so then you have your data, what is existent, and your partners or contractors can then add their own data. The next use case is operation and maintenance. So there is really the damage assessment and equipment maintenance and so on. And this can also be handled and visualized and communicated in a BIM. Then the next use case is the experiment and drilling planning. Here, as you can see, these two Lego workers, they don't see outside of the tunnel, but it would be to plan an experiment. It would be really nice to have the insight into the rock, and like this, it's very useful if you have a BIM with all outside of the tunnel, all infrastructure. Next use case is that you have a basis for simulation. So for example, for ventilation simulation or fire simulation. And here we go a little bit in direction then of a digital twin. And then the next one is the basis for laboratory dismantling. So SwissTopo had to deposit money already for the future dismantling of the lab, and it's for sure very useful if you know what is inside the lab and what has to be dismantled. And last but not least is the public relations. So there is a kind of, you could have a virtual reality or augmented reality application in the visitor center or in the lab. And there, with the data we created there already, we have some work performed with universities. Now, first of all, we had, so it was the beginning of 2023, we started and we had to define the information requirements. So we had to decide, you see this worker, and there are lots of infrastructure assets around him. So we have to decide which assets we want to consider. So what information, what attributes of these assets has to be considered or has to be recorded, and how they should be geometrically represented. So the level of detail of these assets. And for this, we made some work. So we made an inspection of the existing laboratory infrastructure data. So these were CAD or PDF plans, Excel list, and so on. And then there were already some existing applications like the borehole information systems where we could take quite good data. Move is a 3D modeling software for geology, and Fulcrum they used or started using also for some control of asset data in the lab. And then we made a photo documentation. You can see it here from the different assets. And then we started to define the categories. So the asset categories like water system, ventilation. There's also boreholes and geology. So boreholes is also, and it belongs also to infrastructure, but it belongs also to geology. And from these categories, we defined around more than 80 asset types. Here I want you see yourself, there are a lot of different asset types. You had to define how they should be represented and what attributes has to be stored of these. And then to get all the information, a new laser scan of the entire rock laboratory was performed. So more than 400 stations and more than 40 billion points. Then the point cloud had to be cleaned. Here you see the cleaned point cloud, but before the cleaning, there was a scan to BIM process, so that according to the object catalog that was defined, each asset was then extracted geometrically and exactly to the right, to the correct asset type. So these were about more than 4,000 individual assets, so point assets and not linear. And then we had about more than 5 kilometer linear assets like cable trays, power lines, and so on. And after this scan to BIM, I have a little animation. I hope this works, this visible. Here you see the cleaned tunnel mesh. So from the laser scan derived, then in color you see all these assets. They were extracted from the laser scan, and then they were attached to the different asset categories. Here you have a location where you had the roof collapsed of the tunnel. You see bar extensometers here. And now I will still show the size about the tunnel. Here you can see it. We are now in the rock, let's say, and you see all the 1.6 kilometer of the rock laboratory with all these data. You see the anchors that were captured. I will stop here. So until now, we have the man-made infrastructure data, and what we needed still was the geologic data. There we had this 3D model that was in the MOVE software already created by the Monterrey colleagues, and there we have the geologic units inside. Then we have here the geologic contacts. We have the main fault, and if you go closer, we have this about 1,400 boreholes, and we have the faults that were captured when the tunnel was built, so when there was no shotcrete at the tunnel's wall. And with this data, so now we have the data, all the data we need, infrastructure data, geologic data, and now we have to manage this. And for this, we built this BIM Monterrey web application. And in this web app, what is this web app? You have there the central database of the assets. So all the assets, the properties or attributes are stored there, but also for most of the assets, also the geometry is in alphanumerically stored in this database. So this is the cockpit for asset management. So you can get from the other system, import the data from Fulcrum or from as a normal CSV import, or for geological data from the MOVE, these geologic assets, let's say. And then these 3D objects are stored in there. And what is very important, we have a parametric 3D scene generator and a parametric IFC generator. I will show what this means briefly. And there is also a 3D viewer in that is available inside the app. It's a cesium viewer. And then also from the app, you can export then the IFC data to whatever system that can read IFC. And we used IFC 4.3 for this. Now again, for this parametric 3D scene generator and IFC generator, we used parametric modeling. I have a short example of parametric modeling. So here you have a list. So each line are attributes from an anchor. So there is the start point, length, inclination, and so on. And then down here, you have a system. We use the Rhino with the Grasshopper plugin. And here you define the rules, how this object is geometrically constructed or visible. And then by clicking a button, then it creates all the 500, 600 anchor points as they were defined here. And like this, you are really fast by creating these, and it doesn't matter if you go to cesium in this viewer or IFC, you just change what is the exchange format at the end. Now I will give a short insight in this web app. So here we are the assets, and here you have a list of all the assets. You can click here and then you can filter the assets. So what asset type you like, so what tunnel, what gallery you like, from which tunnel meter to what tunnel meter, and then you can apply this filter. Then you get exactly these assets from the database. And there you can then say, I want to create a scene of this. I click there, and then here I can create this scene. If I click open, then it opens in the cesium viewer inside the BIM app. And if I click on download IFC, then it downloads the IFC files. If I click on open, then I land in the cesium viewer. Here you see is the 3D point cloud visualized, and you see all the assets now as cesium tiles. So what by parametric modeling they were created. And then I can click on these objects, and I now clicked here on the first aid kit. You get attributes that are stored from this object, and yeah, that's what is possible in this web application. And then the last thing that's missing from here, I want to perform this IFC export, and then I have here an example where I exported it, all the assets with also the tunnel and the metering and so on, and I opened them then in the free BIM Collab viewer. It's just a viewer to view IFC viewer, and these were the 4.3 files. And I have there also a video of this. So we are now in this free version of the BIM Collab Zoom. Here we see the the wall mesh, so the tunnel mesh. Then I can add the IFC of the geological units. I can query the information of the units here. So what is this unit, and I can also add here, if we don't have so far, but also geotechnical parameters and so on. Then I can add the contacts between these units and also query these objects. And then there is one main fault that goes straight also through the laboratory. This is also very important to have this in 3D. And then if I make a section, so I create a section, I cut the model apart vertically. And then if I go in there, I see now the tunnel is cut, and now I can add the folds. So I close the other ones, and then you see there are all the folds that were captured during the build when the tunnel was built. And here you can see the azimuth, the bedding, if it's bedding parallel, the fold type, fold group, dip angle, and so on of these folds. So this gives me also information about the geological settings or the geomechanical settings. Then now all the assets, so it's in one layer, all the assets, all the 80 asset types with more than 4,000, or at the moment I think there's about 7,000 objects in there. You can add them, and it's really fast. It's just 60 megabytes all the asset, and it performs very fast in this BIM viewer. Then I can zoom in. I can also query all these objects. They also have an icon on there because there are many box asset types, and so if you see this icon on top of the box, you know what kind of object is without clicking on it. And this is a congruence wire box here, recess cover. This is a cable tray. And then I also have the boreholes, and the boreholes are separated in 4 different asset types. So there's the borehole. It's a thin tube, black tube, and it gives the information about the whole borehole. So the metadata, when it was drilled, and the depth of it, and here just some information about this. And then can I add a segment group asset type? Then I see what is the diameter and of the different segments of the boreholes. And then I can add the borehole rock type. There I see what kind of rock is it. So this would be more geological information then. And so I have this all this information from infrastructure objects and geology. Here we see all the objects without the tunnel. It's really a lot of objects, and we see the tunnel metering there. Now I add the tunnel surface. Now we are again in the tunnel, and we can go through the tunnel there. I see all the boreholes that were constructed before the tunnel was built, so there was still rock. And I can go through there and see here are the geological windows on the side. So I have many objects there you can query. And as last, I add a segment, so the tunnel segments. This is what the Monterrey people also wanted. So you can make segments, and each segment has his ID and his metering. So it belongs to 2 meters of the tunnel, and I can add information to this segment. So whether there is damage or so on. So it's not finished yet. So it's the segmentation. The IFC file is finished, but it's not filled with data. So this is a brief introduction of what was done in the last almost 2 years and what were the lessons learned. So what we saw is that a well-structured object catalog is a must. So you really need to know what you want to know of which asset type, and this requires also is time consuming, and there also the people from Monterrey had to work a lot because they know what's inside the tunnel. And then we saw that parametric modeling increases the flexibility and individuality to a high degree and enables efficient interface development. So you can really fast change how your object should look and what attributes should be integrated in IFC or not. And also a generic central data storage optimizes this possibility, because you have the data in one place and you can then perform this parametric modeling. And then at last point, IFC, it's a suitable exchange format, is a small amount of data and this high performance representation. But what we noticed is that the version of 4.3 is not widely supported. So we had a good experience now with the BIM collab, but there are many viewers or systems, they don't support 4.3. As a last slide, I want to say what are the next steps for geological BIM at SwissTopo, or at the Swiss Geological Survey where I work. And there at the BIM Monterrey project, the project completion will be, it's planned by the end of this year, and then the start of the operations from the Monterrey people. So then they start working there and put all the assets and yeah, what they change there in this model. And this will start early 2025. And I can still add, we have at SwissTopo, we have a Swiss boreholes data management application. It's called boreholes.swisscale.ch. And there are currently 35,000 boreholes inside. And there we plan to make an IFC export interface. So it's starting right now, and it should be finished next year. That's from my side. If there are any questions.
Thank you very much, Stefan. Yeah, we do have some questions in the chat. Oh, several questions. Well, they are coming. So I will ask you the first one that was asked was a question about the modeling itself. I mean, not sure that you may answer it, but I will ask them anyway. How did you deal with the interface? So the person is interested in the laboratory test modeling experiments that were considered with, maybe it's that some colleagues of yours that did it. So, but if you have some answer.
So how did you deal with interfaces? So I mean, for the IFC interface, as I understand correctly, we use the geometry gym. So this is a plugin which you can use also by the parametric modeling space, and it also supports 4.3. So for this, we use this, and then we could create the IFC files with this plugin, and this works quite good so far. And as I said, for cesium modeling or visualization, there we use the tiler that is also available in Rhino. But I don't know whether I understand this correctly.
I was also not sure about the interface meaning, because it can be either informatics or maybe geology interface. But I will suggest, if this was not a good answer, if you can stay a bit to the person to precise this question in the chat. We go to the second question. Someone is interested in visiting the site. I don't know if it is possible to go there.
Yes, you can go to monterrey.ch, and there you can. Perhaps I can share this also if I find it. So if you go to monterrey.ch, and there should be the visitor center over here, and there is a registration, so you can registrate or contact them and say how many people you are and when you would like to come.
Fine. Another question, with the perspective to go to digital twin, do you have some kind of monitoring, so information that you catch to maybe?
Yeah, but
this
is something that is now in a conceptual phase. You have a lot of sensors. There are hundreds of sensors inside the lab, and there are data loggers. They log that data, and there is a specific project with a specific system planned to manage all this data. And there we then have to look how is the interface to the BIM. Perhaps that you can in the BIM click on it and get linked to this system where all the data then is measured and visualized. Yeah, or you can query this data. But it's the only like monitoring that's in BIM. So I think BIM is also not the right system for let's say have also for alarming and stuff like this. There are systems that are really made for this, but BIM is more for calibration, for overview. I think it's not the right system for put along. I think what I saw also in Switzerland, many companies deal with this, that the information comes together in BIM, but if you want specific information, then it's linked to the specific system, so to the expert system. So let's say for this topic.
Fine. A question regarding the laser scan model was about how big is it in terms of
yeah. So we have different models. So this one is the low model. You could see there it's not so a nice model. It's nice to go through, but we have also the laser scan, and we have a detailed model. So the small model, I think it's about 12 megabyte in IFC. So it's not that big. So the tunnel mesh, and the other one is then bigger, but I would have to check. I would say it's about 100 or something like this megabyte.
Megabytes. Okay, fine. Okay. A question from my side was how mainstream is what you did in BIM in this project? I mean, is it something very specific to Monterrey, what you wanted to show how can be done, also test what is existing? Is it something that you are able to apply in other projects?
Yes, it was the goal to do this. That was made from GeoBIM, that we use this in the Monterrey BIM project. But as you said, in Monterrey, also the boreholes, they are quite specific. And I think in boreholes is that asset type that is really specific. It depends if you are a hydrogeologist, if you want to take this data or this data. It's if you have geothermics or something like this, there it depends a lot how you can use this or how you can change this. And also in the BIM Monterrey project, the boreholes are quite specific to the demands of the people who work there in the laboratory.
Fine, thank you. Okay, so there is precision regarding the question about modeling. I will offer you the opportunity maybe to answer it directly in the chat to have the discussion with the person if you are okay, Stefan. And we propose to Hilkka to join. So thank you again, Stefan, for this very interesting presentation.
Thank you.
Hilkka, you are here.
Okay, yeah. Thank you. I will share the presentation. Okay. So can you see it now?
Yes, Hilkka, thank you very much.
Okay, that's very good. So yeah, my topic here, and first of all, so thank you very much to invite me here, and that's very good opportunity to tell about our ground investigation service. So that's the topic of my presentation. So I will focus on the geotechnical investigations, what we are collecting and sharing in my organization, the Geological Survey of Finland. And I will tell also about the national standard for ground investigations. I'm a member of a working group. So that the focus is a little bit more narrow than in the previous presentation. But I think this the geotechnical information and the ground investigations, they are the basis and the starting point of all the geotechnical work and analysis calculations, and therefore they deserve a good maintenance, and they should be easily accessed. And so the key player what comes to the ground investigations is the Finnish Transport Infrastructure Agency. So most of the geotechnical surveys are produced by them in Finland, and they wanted already like almost 15 years ago to outsource the maintenance of this register for someone, and the Geological Survey of Finland was very interested to take the data and share them. Mostly the data comes from the public sector organizations, and our register is nowadays the biggest register in Finland what comes to ground investigations. And the idea is to share all the data using the open license. That it means it's all free of charge, and there is no registration or anything like this needed. And all the data once produced with taxpayers' money, so it should be open for everyone. Of course, there are certain special cases, so we need to exercise certain safety precautions. For example, nowadays you can't anymore find the location of municipal water intake plants from the register. That was possible before. But otherwise, the data, we see that's not so sensitive or vulnerable to be shared. And in our service, we have a little bit under 300 visitors every week, and we take new data in every week also. Here's first, I have a map that shows where the locations of the data are. So, of course, where is infrastructure engineering happening, there the data comes from. Then in the middle, there's a table where I show the different methods. There are many geotechnical methods. I was writing the abbreviations of the methods and also the English names there. And on right, then I have the number of the investigations stored every year to the register, and what share of them are owned by Väylä, so the Transport Infrastructure Agency. We also have some data from cities and municipalities, but as you see on the table, there's the list of the names of the municipalities that is providing us data. So there is only 12 municipalities at the moment. We have 300 municipalities in Finland, so of course we could take more of the data. And the data providing to our system is voluntary for the organization. So there is no law in Finland that applies data providing for us, unlike in Netherlands, for example. And I like it like it's voluntary, because then those who provide the data, they must really think that they get some benefit out of our service. We are not very active marketing it, and sometimes it's hard to find the right person from the from the city who to contact, maybe there are more interesting. So I admit we should make more marketing work for this. And when the data comes in, so there is certain quality control. We can make corrections for the metadata, but of course we are never allowed to change the measured data at all. Of course, we are not either responsible of the if the data is correct or not. And let's say we have quite good dialogue between the users of the service. So they will inform us if they find some errors, and we try to correct the errors and remove the drillings that cannot be corrected as soon as possible. Then about the national standard for ground investigations. So this is like the basis of the whole service. Without a good standard, you can't really maintain this kind of service. So all the data that flows in, so it should follow a standard that is good enough. It doesn't have to be perfect, but good enough. I will go to the next one. So here I have an example of the data format what we are using. I would compare this to the AGS format what is used in UK. Like somehow this is very similar and somehow also different. There are 3 examples. First, the weight sounding test, that is the most popular in situ test methods in Finland, and the second example is the undisturbed sample and the analysis, and third one is groundwater well. So this when this data standard and data format was created in the early 90s. So the idea was like it's easy to read for humans, and therefore there is some structure that is not so easy to read from machine anymore. For example, we have the key codes of the row here, 2 letters, and behind that you see, for example, this XY key code. There is X, Y, elevation, date, and also the site ID number. And even though this is easy for me to read as a raw data, so for the software developer who is creating new tools based on this format, so for them this is quite horrible to make coding. So they are quite often asking, like, can we change the format to something easier? And we have some ongoing development work going on for the format. So the last version we released like 5 years ago, and now we started to create a new version of it. And in the beginning, we had to decide, like, are we going to change the entire format to something easier? So from this old ASCII to XML or JSON or something like that. But then we decided, like, okay, let's correct first the necessary parameters there, and do that work, and maybe later we can then start the discussion to change how to change the entire format, because all the design softwares are already using that format, so it will be a major change for the software providers to change everything. And the base of the new versions might sound quite slow, but it's important to remember that this working group has no budget for the work, so we basically do it on top of all the other work. There is then still one slide about the use of the data. So as I told, most of the users are geotechnical designers who have a new site and they come to the system and want to see if there are some new data or the old data available from their site. And we geologists in my survey, we are basically using this data for the geological 3D modeling. I have here an example from the city of Vantaa area. And then my last slide. So this is more like a general overview from the team for infrastructure work in Finland. So we started to create more than 10 years ago already this kind of Finnish InfraBIM framework that the Finnish Transport Infrastructure Agency required to be used on all of their projects already 2015. But all the data, the model data, what is collected, so it doesn't come to my organization. So I don't know if this Väylä has outsourced it somewhere, or if they are collecting them, for example, the model data for themselves. But about this Finnish InfraBIM framework, so I was checking their web pages and they have pretty good documentation also in English. So if somebody is more interested about the format, I can share some links. But yes, thank you. That was the end of my presentation. So yeah, thank you.
Thank you very much, Hilkka. I also support what you said. It's very important to have a common language and standard in order to build some kind of a national database. So that's very nice you are on this way, even if we know it takes time to do that. We do have a question, two questions even. The first one was about the existence of libraries, so libraries in Python, for example, for parsing the Finnish geotech data files. So I guess the answer is, okay, you have your own standard, and is there some tools that can help to parse the content and transfer it in other formats?
Yeah, I'm sorry, but I don't know about these Python libraries because I'm not actually geotechnical engineer from the background, so I was thinking maybe this is more for the field of engineering work.
Mm-hmm. Okay, yeah, I guess this can be answered with the second question was about is there a possibility to access the Finnish database? If there is a Finnish database?
Yes. So, of course, I can put a link here on the chat, for example. So the language is only Finnish, but it's very simple interface or map service, like you just make the search with a search tool, like certain area on a Finnish map where there are some points located, and you can just download the data.
Mm-hmm. Cool. Okay, so there was the first person mentioned that they work with the Swedish Geotechnical Society with having some parser of their own format. So I will share it with you if it can be useful for you in Finland to figure what has been done and if it can be relevant for you. And also this person can also have a look to the Finnish database to figure, well, if there is a big difference with the way the Swedish people organize their data, and if can be relevant too.
Yeah, exactly. This kind of benchmarking with the neighboring country would be very good idea. Yeah.
Yes. The question, another question that popped up was about, is there any possibility to use data field and analyze them by ANN? I'm not sure of ANN. For example.
ANN.
Yeah.
I don't know what that is. Sorry.
Sorry. Artificial neural network. Okay. Thanks, Craig.
Okay. Yeah. That would be very interesting. And of course, we are talking like how to use AI, but we need some partners for that. So we are basically taking care of the raw data and still making our 3D models the, let's say, traditional way. But I acknowledge very well that this is the future, and I'm interested if in other countries there is more advanced way to use the data.
Yeah, thank you. So yeah, I mean, if you are willing to perform some tests on the database, I guess you can take advantage of this one. So the Finnish database is available for everyone. It's open database. Okay.
It is open. Yeah, no registration or anything.
Okay. So yeah, so if you have a successful action on it with a neural network, I see that you can contact Hilkka to explain what is done. Yes, so the data will be. I mean, if you find the time to provide us the link, Hilkka, it seems that some people would be very interesting to just have a look. Even if you mentioned that it is in Finnish, so there can be a language barrier, but still, it seems that people are very thirsty for data. That's a lunchtime, so I understand that.
I will copy paste it to the
if
chat
you
now.
Find time.
Now you can see it there. Okay, the link is also pohjatutkimukset, so there you find it.
That's nice.
Yeah.
Thank you very much, Hilkka.
Thank you.
I see no other question popping up, so I will just tell you thank you very much for sharing the Finnish experience. We can see that there are connection, also distinction with what was presented by Stefan. Big focus on the investigation in Finland, so I agree that's a key point. And from what we can build a lot of things, build models, also identify relationship with the data. So I just would like to congratulate what you're doing on your side, Hilkka. Thank you.
Thank you. Yeah.
All right. I guess that's the time for our third speaker. So Stevan, should we say Stevan or Stefan too?
Yes, Stefan's correct.
Fine. So we do see your screen. Thank you also for accepting our invitation to present what you're doing. I guess if I remember well, you're from Singapore. So you're based in Singapore, is that it?
Yeah,
okay.
Based in Singapore.
Okay, so good evening. Good evening to you. The floor is yours, so please let us know what you're doing there.
Thank you very much for the intro and asking me to come and speak to all of you today. It's very nice in Hilkka's presentation at the end to segue onto the neural networks, because I'm going to be talking a bit more about that in my presentation. So I'll be explaining basically about how we've been using some of this new emerging AI technology to help with data collection, geotechnical data collection. So a little bit about me to get started. So my background is, I studied a master's in civil engineering and then a very specific degree in tunneling and underground space, which was in collaboration with the British Tunneling Society. And then, yeah, I went to work for Morgan Sindall in the UK on Thames Tideway and Crossrail, and then in Singapore for ARA on the Cross Island Line. So I've always been working on tunneling projects. I've also always been really interested in web development and spent about 5 years doing web development, but I do much less of it these days. And yeah, I've been 2.5 years as the founder of the startup Civils.ai. So what is Civils.ai? We build cloud AI, so it runs on the web, for basically automated data collection on construction projects and also helping with compliance checking. So we were founded in January 2022. I basically joined the startup accelerator, which is a bit like The Apprentice, if you've seen that show, where you sort of compete for some investor funding, and we received some funding at the end of that program and launched our company. So we've been used in 7 different countries so far, and we're mainly used in Singapore and Hong Kong today, but also some in the US and in Europe. And we've been working with 25 different companies, mainly helping with geotechnical data collection and checking data. So in this presentation, I'm going to try to give a high, at the start, even though it's just 20 minutes, I'll just give a high level introduction to some of the definitions I'll use, explaining about some of the different AI technologies that can be applied to solve different problems, just to give some background understanding to everyone who potentially, like anyone who needs it. And then I'll explain exactly how we're using it ourselves. So I'll explain how we're using it for geotechnical data collection. And then at the end, I'll basically circle back to the beginning and explain like which of these technologies we're using and how we're using them, to give you a bit of an idea of what's under the hood. So to get started, this is, in my opinion, the most simple explanation of what is meant by AI, which is you have known input and you have a known output. So in the context of like geotechnical engineering, it could be you have a TBM advance rate, which is your known output, and then you have known inputs, which is like the ground conditions, but you're not sure exactly on how those are linked. It could be through like a mathematical function, and basically AI is a part for function approximation. All it is predicting the pattern or the relationship between input data and output data. So it comes down to maths, really. But what do we mean by, so a lot of these definitions can be used a bit interchangeably, but what's really meant by data science, AI, machine learning, like what do these things all mean? So when people talk about data science, that's normally talking about the overall subject. So this could be the subject you study at university. It's the most broadly encompassing term, and that can include things like handling data and the way it's being stored and fed into different like systems. So it also includes a lot on the data handling side. But when people talk about AI, so artificial intelligence, the definition of that is just a non-natural construct which can take a decision without human intervention. So it's not biological. The definition is just something we don't need to necessarily supervise in order for it to operate. So it's quite a broad definition. But actually, machine learning is just one approach to creating AI algorithms. So there are actually other such approaches. So one of the more traditional methods was these rule-based systems where you create many if-else statements and create some intelligence in the system, but it just follows certain paths that you've hard-coded for it. And these still get used quite a lot today in these expert systems. But yeah, basically machine learning is just one branch of AI. Neural networks is a technology that gets used for this function approximation that I was talking about at the beginning. So when people talk about neural networks, that's just one type of technology that can be used for that problem. And deep learning is basically any neural network with more than 2 layers. So it's like a more complicated neural network. So these are a lot of the most common definitions that get used. I just wanted to sort of explain those. An interesting thing about this slide is that it shows that many of us in geotechnical engineering are already using the foundations of machine learning and AI in our work every day. So this chart here is it's an empirical chart. It's showing like the stand-up time of unsupported caverns, like rock caverns. And each point that you see on this chart is a different data point from a past project. And what the author of this chart did was they found a relationship between all these past projects that we can then use in feasibility studies or early stage designs to understand the problem more easily by using the past project data. But this is actually a machine learning problem. So creating these lines of best fit is function approximation. And this is actually a machine learning problem. So I quite like this chart because this slide, because it shows even when people say, oh, I don't trust AI, I don't want to use AI. In fact, most of us are using some foundations of it in our work already. But the question is like, how best is it to, in this case, like approximate these functions in this formula? Is it through human judgment and their expert understanding, or is it through an AI algorithm? So yeah. And there are basically different technologies available to solving different types of problems. Some are better suited to certain problems than others. So in the last case, it could be cast as a classical machine learning problem, because what we're doing there is we're using something like potentially linear regression or some kind of line of best fit through the data. So that tends to be classical machine learning. But there are other types of technology which can be used for solving different types of problems. So vision intelligence is good for convolutional neural networks, and vision intelligence is good for detecting objects in images. You also have things like transformer models down here on the bottom left, which large language models that have become really popular these days. But you have others like graphical neural networks, finding recommendations and relationships between different objects. So when you're approaching a problem and you want to solve it, try and solve it with AI, normally you'll try to identify, a data scientist will try to identify which type of technology out of these or more is best suited to solve that problem. So how are we applying this technology for geotechnical engineering? So basically gathering and understanding site data is really hard. From 10 documents on national registers, you have a lot of unstructured documents with a lot of valuable data inside them. And the process that we have been using for many years is that we will review those and type information out manually. And it's just seen as like part of the work or part of the project to go through all of this and do it manually. And you know, the stakes are very high. So this is like the problem we're trying to solve as a startup, is we're trying to help with spotting and like getting better data out of these documents more reliably, and not putting a lot of pressure on people to do this all manually. So we're trying to help with eliminating like risks and rework that gets passed on to the construction phase. So what we've built with Civils.ai is a tool for, so it's all on the web, and basically we can read in tender documents, historical documents, and once we've read that information in, we can start to extract. So we can extract like key structured data from it. So you can import site investigation reports. We can extract structured data from those, like borehole logs. And we can also do ongoing compliance checking. So once all of this information from the tender documents and historic documents is uploaded, we can also help with checking back against that information during project delivery. And so for data extraction, so the system we built today, you can drag and drop geotechnical reports in PDF, and our system will analyze the documents and then we'll read out that information. So we've built a kind of lightweight GIS system as well for previewing and looking through the data. And we basically extract each one of those borehole logs out into a different row. So each row is a different borehole log sheet, and we read off the information and then also extract that data out into Excel, AGS files, DXF, so bin files, and also GIS files as well. So we're kind of like a middle layer of helping to extract data from these documents and to make it digital. We can extract quite a wide range of different data from the borehole logs, so things like the metadata, like borehole name, project name, coordinates, and identifying the coordinate system. Even sometimes when it's not given, we've built something for calculating it. And then the drilling dates, so like the start date and the end date. We also can do the ground level and the water strike, which is like the first water strike that's encountered. And then the classifications of the different layers and the descriptions of the layers, thicknesses, weathering. And some in situ tests, we can't do all of them, but we can do FPT counts, RQDs, TCRs, SCRs, and shear bane tests, and also pocket penetrometers. But we can't do CPTs. And we can read from entire reports, so you can upload many boreholes in one report, and we can identify the individual borehole logs and extract them, and also read from handwritten and scanned documents. So we can read from, so long as you can read it as well. We're not better than the human eye, but yeah, we can read from handwritten and scanned documents as well. And yeah, more recently, we've also been working on extracting other types of unstructured data. So we've been, it's not like publicly released yet, but we've got something which allows you to create forms and specify what type of data you want to read out. So you can read out environmental data. We're working on lab testing data as well, topographic, site constraints, as-built information. So you can kind of specify what you want to read out. And then, yeah, the idea is into Excel for now. And also, once all that information's in the system, to enable people to be able to go back and query back against it. So for the, let's say, more project delivery or checking for compliance, you can also query back against all the information that's uploaded. We've been working on a feature for checking it against building codes and regulations and things like that. So some element of like cross-checking information as well and comparing. But again, this is not like publicly released. It's like a beta product right now. And so we've been helping a lot on tenders. That's the main thing that we've been doing. And one or two like big archives of documents we've helped to digitize. And the main thing at the moment we save is time. So it's a time-saving tool, which is obviously important in bids. And yeah, like this is one case study from Singapore on a cross-island line package. I can't say who it was with, but then yeah, they won the work at the end. So that was like the most important thing to us. And then yeah, with the querying side as well, we've had some case studies where people have done pilots with that, and the number of queries that they've asked over a 3-month period and the level of accuracy. So I'd say we're doing quite well in terms of the quality of the answers we're providing from ongoing querying against the documents. And so this is a little bit of a look at like how how we've actually built Civils.ai as well. So out of all of these available technologies that I was showing you earlier on, there's two which we use a lot, and it's the convolutional neural networks, so vision intelligence and object recognition, and then also transformer models. So we use some large language model type technology as well. So for these vision intelligence techniques, so a lot of the geotechnical data is in documents that look like this, right, or whole logs and lab testing. So what you'll find with a challenge like this is that you have many different styles. So you have many different formats. Sometimes you have the descriptions here on the left. Sometimes they're on the right. Sometimes you have different names for these things like description, like levels or depths. So it's always interchanging. So the thing that we did was we labeled lots and lots of these borehole logs by using some of the open data, like BGS borehole logs actually. So we labeled lots and lots of these and trained like a vision intelligence model to be able to predict where the objects are, where the information is, and to turn this into structured data. So you have to do this like many times to be able to capture the variety of the different like styles and formats which are used on projects across all of the different sort of providers of borehole logs. And then we also use transformer techniques. So the way these work is we turn all of the text and tables that you see, and also some images and diagrams, into a mathematical representation of what all of that wording is. So each point that you see here, you could imagine it's a different paragraph that's read from this document. So we turn it into this mathematical representation, basically called a vector space, which represents all of the words from this document. A way to sort of understand this is that it looks a bit like, sorry, my computer's slowing down a lot for some reason, but basically it's a mathematical representation of what all these words mean, and the closer they are in the vector space, the more relevant they are to each other. So geotechnical could be associated with the word settlement more closely than the word deflection. So steelwork, let's say, for example, would be a word that you might use more often with something associated with deflection. Geotechnical, you'd associate it with Eurocode 7, let's say. Steelwork could be associated with like Eurocode 3, for example. So these are closer, so geotechnical's further away from Eurocode 3. So this is the way to kind of imagine the way in which this like vector space works is through spatial relationships between words. So we do this with many words and documents. So, but why do we use these together? So basically what happens is you run into, okay, I'll just explain it fully. So for creating the vision intelligence models, you have to get lots and lots of data and label it like I was showing in the slide before. And then you use a library like YOLO to train a convolutional neural network. And at the end of this, it can label images for you. The approach with transformer models is that you could actually just pass this image in or text in, and you can use transformer models to basically do the same thing just by giving it instructions. So it's a lot more flexible. The thing here is that with this traditional approach, you need lots and lots of data, and it's like, where does that data come from? So with open source resources, there's only so much that's in the public domain to be able to improve the system. And beyond that, you need to start looking at like smarter ways in order to improve the results. So our solution to that was basically to start looking at using also transformer models as a way to be able to like capture more data and to be able to sort of extend the capabilities of what we were able to do. So yeah, the strengths of like these vision intelligence models is that they're very repeatable and predictable. They'll sort of behave in the same way if you feed in the same data, whereas these transformer models are more like probabilistic, but they're much more flexible, and you can just change prompts or instructions in order to actually extend the capabilities. So just to basically wrap up, let's say maybe like the key takeaway of what we're doing and like what we can help with is we can help to like basically extract data from all of these unstructured documents. And the main thing we're doing at the moment is like feeding that into some downstream tools like OpenGround and Leapfrog. And this is like the main thing we're used for today. So yeah, thank you very much for listening. And if you're interested in a trial as well, please do drop me an email. And are there any questions at all?
Thank you very much, Stefan. I don't know if it was your question with Hilkka regarding artificial neural network, but it seems to be a nice transition.
That wasn't actually.
All right, so so if people asking or say why do we invite this guy, because it's not about National Geotech Database, it's more about what we can do when we have access to data, what can be performed. So I think you highlight limitation regarding, okay, we have heterogeneous data, so we have to cope with this. And you provide some solution for that. And also the question was, with which kind of data did you have the opportunity to work? So in Singapore, but maybe from other countries?
As in, most of our work that we've done, like on projects, has been in Singapore and Hong Kong. But we've also been like in talks with quite a few of the national databases about potentially like working with them to digitize like sections or like all of their national database. So we've been exploring that quite a bit, and also company archives. So there's quite a few companies where they have big GIS systems full of borehole logs, which are all in PDFs, and then we've been speaking with them about helping to convert all that information so they can use it more easily.
Indeed. So you mentioned Singapore and Hong Kong. So I see some kind of connection between the two. Maybe you use AGS format. Was this data stored in AGS format?
4.1 for the extraction that we can convert it into. So the PDFs, we can convert those into 4.1.
That certainly helps a lot in order to do some common developments, to have some kind of standard. Another question that was asked to you is regarding, do you only export files from the example, the GIS, or do you also have some kind of API?
Oh yeah, we do. Yeah, we have like an API, so we can send back JSON data as well, and we can also send back Excel, and AGS. So that's supported on the API at the moment. But in terms of like sending reports in, it's exactly the same. It's like the same capabilities. The only limitation is that it's JSON, Excel, and AGS are the only export supported.
Nice. And we also had a comment that we can use AI to determine spatial variability of soil parameters, for example, friction angle and cohesion. So yeah, it has become a question in the meantime. Can you determine spatial variability of soil parameters from GitHub?
We started to do a bit of that, and then lots of people discouraged us from doing it. Actually, they said to not go in that direction and to focus more on just like data extraction rather than interpretation. But yeah, I think it's definitely possible, and it's really promising, or like it would be a really interesting thing to do. But the thing that we wanted to do was just like focus on being just like factual rather than being interpretive, because we thought it'd be very hard to because we had some questions about also renaming like classifications to more modern classifications. So if there's old borehole logs that previously had a different naming convention, so we thought about that for a long time, but we were a bit worried about a bit worried about how we would have to make that very clear where we've made an interpretation, and maybe people wouldn't notice where we have made the changes and where we haven't. So we just stuck with, the only one we've done is from feet into meters, actually. For historic logs, you can convert from feet into meters.
Yeah, indeed. So the big question of semantics in order to be sure that your data can be transferred in another format. Thank you, Stefan. Okay, so it seems there is no more question for you. Thank you very much again for staying awakened. I don't know which time is it in Singapore, but certainly it's quite late. So we will go for the last presentation. Ed, are you with us?
Yeah, hello. How are you doing?
Fine, Ed. Good to see you. So not to see you, good to hear you for now. We don't see you yet, but we hope to see you soon.
I've turned the camera on.
Much better.
Slow government Wi-Fi. Okay.
So we do see your screen. And we see your screen even full screen. Go ahead, Ed.
Okay.
20 minutes.
Thank you for inviting me. Let's get into it. So, conclusions first. Then you can all have a nap if you want. Subsurface obviously impacts and supports the surface. That's why it's important. And the value of our subsurface data and your subsurface data is dramatically increased by submitting it to a repository somewhere as open data and allowing it to be reused, ideally in interoperable formats, like AGS or AGSI. In the use case specifically, the construction playbook means it's now a requirement for any public sector projects that any ground investigation data collected needs to come back to the BGS in AGS format, which is a fantastic little amendment that they made to that now. Obviously, to make all this work, standards matter, metadata matters, data models, data services, and the encodings that are used for that data. And in support of these standards and newer standards, the BGS has implemented some of the newer standards from the OGC, including OGC API features, tiles, records, and we're doing more work to get data out as linked data and having our vocabularies on there and permanent identifiers for a number of geospatial features. So BGS, for a bit of a background, the British Geological Survey, founded in 1835 with the UK government's custodian of geoscientific information. About 600 people spread around England, Scotland, Wales, and Northern Ireland. Part of the BGS, although a separate group as such as the National Geoscience Data Centre, whose funded and purpose in government is to look after all data that's funded by Natural Environment Research Council grants, any voluntary data deposits like geotechnical drilling data or aggregate production data, and then there's also statutory data deposits around minerals, water, and petroleum drilling that is mandated to come to us. And the NGDC look after all of that. As part of that, that's obviously the remit is mainly to do that for the public good and for the taxpayer. And this all fits in with the BGS's broader strategy around maps and models for the 21st century, and to make this data open and available as possible. And this data isn't just geotechnical data. This is geological maps, boreholes, groundwater, minerals, geohazard data, landslides, earthquakes, etc. Fair data, so I said about making subsurface data fair. Just wanted to clarify the difference between fair and open data. There's similarities and there's overlap, but they're not the same thing. Key difference being that open data should be available to everyone to access, use, and share with no license, copyright, or patent restrictions. So and that's open data. Fair data, however, uses the term accessible for the A, and this means accessible by an appropriate person, an appropriate time, in an appropriate way. So fair data might be open data, but it also might not be, as long as the accessibility is well defined, so it's understandable about when and who can access it. It would still be fair data, even if it wasn't open data. We're going to interoperability challenges. These are all the sort of things that people come up with in the science groups or in the BGS, and then also more widely in industry, about how to share data, how to deliver data, having a common language and common vocabularies to speak, to pull their things together, and security issues relating to exchange of spatial data. So these are some of the things that standards try to solve. In the UK, we're quite lucky. We've got a fairly good community around in the data standards space, and there's a number of good documents and guidance available. So there's the UK Geospatial Standards Register, the W3C, make the spatial data on the web best practice guidelines. The UK government also has digital service standards, and there's the Inspire directives for the EU. And data.gov has its own metadata requirements, and the UN GGIM also has a guide for standards for geospatial data. So about the UK's Geospatial Data Standards Register specifically, even if you're not a government data provider, it's still a really useful document in terms of how you might want to share data as an organisation. So it's sort of got the hit list of which formats you should use as a top preference, what metadata standards you use as a top preference, recommended coordinate reference systems and transformation systems that you should use to transfer between different CRSs. And that's all in there, and that's available on the web. And yeah, I recommend checking that out. I say, geodata should easily be findable and accessible in a digital format. Quality, there is a standard for data quality, which is 19157. Ideally, people should try and meet that. Essentially, that's an upgraded metadata standard that sort of makes sure you describe your data really, really well and let people understand what the limitations to using it are, where there's challenges, any plus or minus number of meters, how the data was collected, and make that all really, really transparent. In our opinions, the BGS, we think seamless geodata and the value-added geodata is less important than the actual findability and accessing in the first place. It's about getting the basics right first. And it's also important that things are reusable, that are in fair data, and making sure that all data has got license or copyright attached to it, even if that license is the unlicensed, and you can do what you want with it, just to make that really, really clear for end users. Otherwise, they can't reuse it. And obviously having good infrastructure as an organization, so making sure that things are up as near to 24/7 as they possibly can be. Now getting into geotechnical data specifically. So in the UK context, there's an estimate of about 500,000 boreholes or pits are sunk every year for construction infrastructure. The BGS ourselves, we hold 1.4 million borehole records since we started collecting all that, which is 100 years ago plus now. And thousands of new records are added every single year. And this data really is vital for the construction industry and academic research also. It's estimated that about 50% of project delays are caused by not understanding ground conditions. And the government, and by extension BGS, obviously encourages an open data approach. We'd estimate of those sort of 500,000 boreholes, about 80% of them aren't coming to us. And that results in an estimated loss of data and knowledge to the UK economy in the region of 150 to 200 million pounds per year. So that's obviously a big, big loss in that data not coming where it can be reused. There's an example of where reuse is good and does have value. Recently for the Farringdon Station on the Elizabeth line, we helped make the 3D model for that, utilizing a lot of our historical borehole data that we held. That's all open data that other people could have access to as well. And the estimated reduction was 70% reduction in tunnel probing, and obviously costs associated with that. So it's, yeah, significant saving from using that open data in the real world. Geotechnical data standards that are available to use for you. There's the DIGS standard, which is an XML-based standard, which is mainly taking hold in North America. And then there's our favorite, the AGS data format, which started out in the UK, but has also been adopted in various flavors in Australia, New Zealand, Hong Kong, and there's growing use across Europe and Asia. First went in 1992, so it's quite an old standard. It's text-based format, so it looks like a general text file with various groups all the way down, and there's a hierarchy of groups to go with that. There's some other standards that are more recent that are coming out or are out, which is the AGS piling standard and the AGSI standard for ground models. They're not quite as mature just yet, so yeah, the adoption just sort of starting to pick up on those, but they've got some really nice advantages to using those as well. For BGS, in terms of how we manage this, generally we've got a ingestion, storage, and delivery workflow, which works well for us. Files are deposited in a data deposit application form, which is sort of a six-step process of filling in various bits of metadata about the file that you're going to submit and confirming that you've got ownership or permission from the owner to submit that file. We have a validator that people are encouraged to use to validate their AGS file before they submit it. So we've got an older one that's suitable for AGS3 files, if anyone finds those down the back of the couch. If it's AGS4, though, we've got a new one, and that utilizes the official AGS Data Management Working Group's Python library. So you get the same results from theirs as you would from ours. So it's a relatively simple process, and the data should be available in about 5 days, which I'll just sort of walk you through what happens with the data when it comes in. This is the data validation tool. So it does two things. So the AGS validation library just checks you against the AGS rules as written. The BGS one also has an additional step of being able to check you against the BGS data submission rules, which is more looking at the actual content of the file, not only that you're meeting the AGS rules, it's more around the schema and the formatting of the file rather than the actual content. So yeah, that's available for everybody, and that's also available with programmatic access. So there's an API endpoint you can use as well if you wanted to script something to go and churn through a selection of files if you had them. That's available, and there's no restrictions on using that API currently. Once that data has come into us, either manually or there is also, in addition to the manual form that I discussed a couple of slides previously, there is a API for AGS ingestion, which is what's used by Bentley Systems in some of their software if you want to submit data to the BGS. If there's any software vendors out there that I'm speaking to today and you'd also like to implement our AGS ingestion API, so data could get sent directly to BGS, you're more than welcome. Please get in touch. I'll help you out with how you need to do that. When that stage is complete, then there's an initial validation step, checking about the format's correct, and then the file saved on our storage and made available in about 3 days using the deposited data search. Then there's a more detailed validation step where we check the locations and where they are and that the file's written correctly and there's no data missing and all the sample groups match the other sample groups, etc. And then that was brought into the actual BGS database, which then that data's then available via GeoIndex or on our APIs for download in 10 days-ish or less than 10 days is our target for that. The data is held in our Oracle database. It's a version agnostic geotechnical data store, so we can build AGS3 or AGS4 files from our data store, depending on what people are after. And for getting the data back out from that database, we've got our online portals like GeoIndex. On the AGS validation page, we've also got a data discovery page on the validator. We've got geospatial data downloads available on request. We've got API and front end at AGS API that lets you query by borehole ID or by polygon area and it'll extract the AGS data for you. We've also got our web services, web app services, web feature services. And then we've got the actual original data that was submitted is available through our NGDC deposit data search. So this is just another look at the validator. I think I've left that in by mistake, so that is a double up of the previous slide. We've also got our AGS API features endpoint now. So this has got data for the AGS boreholes in it. So this is then compatible with QGIS and in ARC to get that data live, with a live link to the BGS database. So if you try and download the spatial data for BGS boreholes, that's updated on approximately a 6-weekly cycle, whereas the actual BGS database tables themselves and GeoIndex are on a weekly update cycle. If you use the API, then you'll get the weekly updates, and you get sort of that live link to the data. So if you want to query things and see what's been the latest that's added, or you want to make sure that your borehole you submitted is there 10 days after, this would be the way you do that. And we've got a few different data collections available there: landslides, earthquakes, got the AGS boreholes, and all our other boreholes are also available that way. We've also got the scans when they're available as PDF, and that's actually has had a relatively recent update about 6 months ago. So previously we couldn't display large scans if they're more than a megabyte. You had to have page results, whereas the new version, it makes one large PDF return. They're not paged, which is much nicer to navigate through. We've also got our AGS logs API. So this is getting the data from our database and then drawing it into a visual borehole log. And that's also had a update recently. So now there's more data available on those logs, and a bit of an improved visualization on those. And that was on at the same time as the last one, about 6 months ago or so. So yeah, this page just sort of lists all the different ways you can get the data. This is more for if people want to read this later and then go and find the URLs to check them out. That's all written in there for you. Future, what's going to happen with the AGS data? At the moment, the AGS validator Python library has had a version 1 release. That was about a month ago. The BGS, we haven't quite managed to implement that just yet, but it will be coming to our validator soon. It just tightens up some of the rules a little bit. But our validator is still putting out, it's still doing the validation correctly. It's just, yeah, there's some exceptions that might slip through on R1, because we're using version 0.5. The data management working group is also looking at transfer of lab data, and also looking at making a new AGS API standard, thinking about cloud data transfer. And we've started looking at what we're thinking about for AGS 5 and what that might look like. And then there's other work going on in the AGS space around BIM and digital twins, and how to make AGS and GIS and BIM formats all play nicely together. So yeah, and obviously we're very committed to the AGS file format. We've built a lot of our ingestion and data delivery processes around that standard. So yeah, we're committed to the standard and further development and adoption of it more widely. I mentioned around the construction of playbook. So this has got an update 2022, so it's a couple of years now, but some people still aren't aware of it. But yeah, there's a new template clause added for subsurface data sharing. As I say, so it's now a requirement for any public sector projects. So whether you're doing drilling at a school or you're making HS2, that data ideally should come to the BGS as soon as practical in AGS format for re-access, and make sure that data is available for the long term. And importantly, that data is marked as open data and not confidential when it's submitted, and that's all in that subsurface data sharing clause to be included in contracts on public sector projects. And there's a little mention about why you'd want to do these things. So of those sort of 1.4 million boreholes that the BGS have got, there's about 20% of them are currently confidential. And we can see them internally, but you guys can't see them externally, and we're not able to release them. So we continue to engage with organizations, some of which might be here today, about what we can do to try and get that data made into open data and available for everyone else to reuse and benefit from. Yeah, so it's a longer term sort of legacy issue that we end up with. Some examples then of how this data is used and other standards around in the subsurface space is the National Underground Asset Register. So this is in the UK. There's estimated to be more than 4 million kilometers of underground pipes and cables, and many accidental strikes every year of those, with a cost of 2.4 billion annually in delays and repairs. So the government sensibly thought, let's try and make a standardized digital map of those buried assets. But it's obviously a very challenging task. A lot of that data is held by different bodies in different formats and different data models. There's over 650 to try and join together and make those work. But it's been achieved with lots of data standards, namely using the MUDI standard, using OGC API, using GeoPackage, using JSON-FG because JSON is in WGS84 only, where JSON-FG allows you to have your data in BNG. And some other imagery formats. You also have to store image as well. So that's been a big effort then to get all these different providers on board and map their data delivery to these standards. But now they've got that working. There's some obviously really advantages for that community. So you can search based on postcodes or UPRNs or addresses or polygons. And if you find a cable or something that's moved or it's not where you expect it to be, you can submit those updates back to NUR to then feed back to the data owners that they might need to tweak their geometries a little bit. So yeah, this is all coming soon. In terms of what next and what the BGS does with the AGS data that's submitted, the next step in the process is our National Geotechnical Properties Database. So this started up in the 90s, and there was lots of data manually put in from paper and PDF ground investigation reports. Although more recently, obviously, AGS data ingestion systems have made that process much more streamlined, and the data sort of almost automatically put into the Geotechnical Properties Database. So this is really useful. There's over 200,000 borehole records. About 80% of that's from AGS data. The data model that's using is mainly made around AGS3. That's from when it started. But yeah, we can still get stuff out or you can make stuff come out in different formats. And yeah, this is what we're doing a more stringent check on the AGS data before it comes into this database. But importantly, the big difference is lithology and stratigraphy are validated and made to match the BGS lexicon. Or it's added if it's absent. The geologists actually sit down and put down what the lithology or stratigraphy should be in that hole based on the descriptions that are in there. And then we have a lot of records then for many different test parameters, which is a fantastic resource. So this is then used for various formation studies that we do, engineering geology maps for the UK, various 3D property models. There's a project at the moment called Common Ground, which is looking at how this data could be more widely shared with the community, and what that might look like. So yeah, in terms of what next, at the BGS, we're looking to try and improve that data discoverability and that user journey. So you can the idea is they're meant to be 2 clicks from data is the idea is where we're trying to get to. And we want to integrate our metadata better with our other tools, with GeoIndex, with the AGS API data discovery pages, and with our metadata catalogs. And some of the standard documentation could do with improvement, including Muddy and OGC API to help people understand how they can implement those. And yeah, we want to be able to deliver that geotechnical properties database in a format that's easy for people to use, so you can get your the engineering properties for a formation, a horizon in an area, or even across a horizon in an area, and yeah, how to get that to people, whether it's as an AGS file or as a coverage JSON or geopackage or spatial light. There's a few different options. We need to see what the community want from that, and what we can what that data can be crowbarred into. We'd like to get our vocabularies expanded. There's other vocabularies available elsewhere, and try and map between those vocabularies, BGS's own and international ones. And yeah, we've got some more work to do in terms of permanent identifiers for things, whether it's boreholes, sensors, so that when people are referring to a feature, it's then definitive, like a DOI. And yeah, that's what the BGS is up to at the moment. Thank you. I don't know how I was for time there, but yeah.
It's perfect, Ed. Thank you very much. A huge load of information about what you were doing in BGS. I guess people didn't get time to write some question because it was so quick and provides so much information that it seems that no question came.
There's a bit of a brain dump. Everything we do, all the time, everywhere. Yeah.
Yeah, I have a question regarding the construction playbook. Sorry,
playbook.
Construction playbook. Do you, from the time that you wrote this document and now it's 2 years, it's 2 years from now.
That's not a document that's written by us. That's written by central government writes that document, and it was sort of our recommendation to add the AGS clause into it. So that's a very long document that specifies how you should write a contract for a public sector infrastructure project. And so far, we haven't seen a huge uptick in data deliveries, but that's kind of to be expected because 2 years probably isn't very long from something going into contracting guidelines for someone to start a project, write the contract, actually break ground, finish it, and then send it to us for a large, if it was for building a road or something like that. So that's the benefits that I think are still to come. At the moment, has been a drastic uptick, and then that sort of is not clear, particularly about what sort of public sector projects that is related to. So if you do a small extension on a school, does that count, or is it only if you build a railway station or a rail line? Where's the line on that public sector infrastructure job?
Thanks. Yeah, I was asking you if you already see some progress, but you do already see that there is a move in order to share the data, that you see that you get more data from the providers.
We definitely had more data coming from data providers, whether that's related to the construction playbook or whether that's just good outreach and people getting on board with this idea. You can't tell. And then I didn't mention that sort of go along with this, we've also been having a dig to share initiative. There's a bit of a crowdsourced way of getting some more data done. So people have been encouraged to go and look at our borehole scan records where we don't have AGS data, and to digitize those, make them into AGS data, then submit them. And we've had quite a lot of engagement from that, and quite a huge number of records. And some people I think have been turning into a bit of a competition change so that they can get their corner of a county with more AGS data than someone else by submitting stuff, which is great.
Thanks.
So a question from Ben, is that?
Comment. Hi, Ben.
So that's, similar to what we're doing with the AGS data. I've not heard about that, but it's certainly something that we'd be interested in. The difficulty with those crowdsourcing things is there's a maintenance overhead for ourselves in terms of building the systems to enable people to do that, and then maintaining those systems, which is unfortunately never cheap. But yes, it's certainly something we'd be interested in having a conversation about.
That's fine. Okay, I don't see other questions. People are very impressed by what you did and your team, so that's very nice. Thank you. Thank you for having attended this workshop. I will just propose you a kind of small wrap-up and give you some information about next things we may be doing together. So you had with this workshop some overview of national geotech databases and asset registers. So what is already done in some countries, what is also to be done in the near future, about data and services that are available, how they get the data, what are the governance and regulations that are already in place or should be in place. So that's something we will continue with more examples. Certainly, no all countries had the opportunities to present what they are doing. Also, some countries are making some progress, so we may expect to have some updates of what is done by some countries that already presented. We continue with our workshop. The next one will be in early 2025, not 2024. We will not go back in the past. It will be the 6th. And we expect to discuss connection with other TCs. So their discussion with which one we will address it. Already in place, TC 309 about machine learning. We will also have a look to collaboration with JTC2 regarding the standards, ITA, maybe other people on that thing. But still, even if we have things in mind, if you have some topic or presentation you would like to share with us, or maybe participate to one of our workshop as a presenter, please just let us know by contacting us with this link. I just would like to remind you something. Yes, ISSMGE 2026 is in 2 years, but the submission deadline is next month. So if you have something you would like to share in this conference, I would strongly suggest you to take care about the deadline, and remembering you that if you choose a topic regarding BIM and digital twins, yeah, you may be in contact with us, and maybe you will be able to present in our session. Once again, you can follow us on our website, on LinkedIn, on YouTube. And again, if you are interested in becoming ISSMGE TC222 member, it's possible. Please get in touch with National Society. And if you are not, you don't already know who is your National Society, then there is a list on the ISSMGE website. So thank you very much again for the presenters, people that attended this meeting. As Magnus said, we will try to share the content as much as we can. And we will say goodbye to you and wishing you a nice day. And we'll see you in our next workshop in 2075. Have a nice day. Bye-bye.